Quality Council of India. I welcome all the participants to this webinar on practice of lean and Toyota production system. Before we begin with the webinar, let me give you a brief about QCI. Quality Council of India was established as an autonomous body under the Ministry of Commerce and Industry with the mission to lead nationwide quality movement. Our nodal point in the Ministry of Commerce and Industry is the Department for Promotion of Industry and Internal Trade, DPIIT. QCI is driven by the dynamic leadership of our chairman, Mr. Adil Zainul Bhai, and Secretary General Dr. Ravi P. Singh. As an apex quality organization, QCI has 5 constituent boards. First, National Accreditation Board for Certification Bodies, NABCB, which provides internationally recognized accreditation services to the certification and inspection bodies with respect to ISO standards and other requirements. Second, National Accreditation Board for Education and Training, NABET, which offers accreditation program for quality school governance in the country and is also involved in other programs like accreditation of environment impact assessment consultant organization. Third, National Accreditation Board for Hospitals and Healthcare Providers, NABH, which provides accreditation to hospitals, blood banks, community healthcare center, Ayush hospitals, and many more. Fourth, National Accreditation Board for Testing and Calibration Laboratories, NABL, which provides accreditation to testing, calibration, and medical laboratories. Fifth, National Board for Quality Promotion, NBQP, is dedicated to promote quality in all walks of life. NBQP board promotes quality through various programs and events like Quality Conclaves, QCI DL Shah Quality Awards, QCI Quality Champion Award, Professor S.K. Joshi Laboratory Excellence Award, registration scheme for consultants and auditors, etc. We also run QCI Professional Membership Scheme for individuals and organizations, which provides a great opportunity for learning and networking. This webinar is also brought to you by NBQP. QCI also has special project divisions, including Project Planning and Implementation Division, PPID, which is involved in several projects with various ministries and departments. Some of the projects of PPID are Swachh Bharat Sarvekshan, ODF surveys, DARPG reforms, and many more. Another division is Project Analysis and Documentation Division, PADD, which is involved in the development of new schemes like INDIGAP, Yoga certification schemes, and others. Zero Defect Z is yet another division which leads various projects of national importance with a focus on Atmanirbhar Bharat. The division is involved in flagship program of Ministry of Micro, Small and Medium Enterprises, Ministry of Tourism, Ministry of Defense, Ministry of Tour and others. Our training and capacity building TCB cell is involved in training, e-learning courses and capacity building programs. With all its constituent boards and division, QCI continuously leads its mission and of nationwide quality movement. Our today's webinar is about practice of lean and Toyota production system. The Toyota production system is Toyota's unique approach to manufacturing. It is the basis for much of the lean production movement that has dominated manufacturing trends for several decades. The Toyota production system has been considered a potent method for making products because it is an effective tool for producing the ultimate goal, profit. To achieve this purpose, the primary goal of the Toyota production system is cost reduction or improvement of productivity, which are attained through the elimination of various wastes such as excessive inventory and excessive workforce. This was summarized by Taichi Ono, founder of TPS, as he said, all we are doing is looking at the timeline from the moment the customer gives us an order to the point we collect the cash. And we are reducing that timeline by removing the non-value added waste. Therefore, the goal of TPS is to reduce the timeline from the time an order is received until the time it is delivered to the actual customer. And this revolutionary system not only helped Toyota become one of the most profitable organizations, but also transformed the manufacturing systems across the globe, enhancing productivity and profitability. The practice of lean and Toyota production system is relevant even today and if implemented rightly. It has a potential to transform an organization by enhancing quality and productivity, leading to higher profits. To provide deeper insights on this topic, we have with us Mr. Shishir Bharadwaj, who is an avant-garde consultant, has been guiding manufacturing companies to develop their own capabilities for developing applications and tools with the current resources, which can put them on the process of ongoing improvement. Having worked in discrete manufacturing industries for 20 years, with companies from automotive industries to electronics to aerospace and steel, he has helped in developing innovative production scheduling and material requirement planning systems. He has been the trainer of master trainers of the for the Z maturity assessment model for QCI and the creator of manufacturing competitiveness e-learning course on the Swayam portal, which is also one of the best and most popular eQuest courses. I'm sure you all would benefit immensely from his knowledge and wisdom. Before we move ahead, I would like to announce that the questions will be taken up at the end. You may type your questions in the chat box and these will be announced during Q&A session. With this, I welcome Mr. Bharadwaj. Over to you, Shishir.
Thank you so much, Pooja. Am I audible?
Yes.
Okay. Thank you so much, Pooja, for a very nice and a crisp introduction, along with the overview of what Toyota has managed to achieve over the years. And incidentally, if we talk about it, we are nearly 50 years down the Toyota production system, which started in the early 70s. And now we are sitting in 2022, still discussing about it. In itself, we can say that you can imagine it has lasted the test of time. By that, I mean it has evolved over a period of time. And since it's lasted so much of time, one can live with the assumption that the principles set in motion in the early 70s were so powerful enough that the system could adopt and change as and when the environment changed along. So the fundamentals of Toyota production system are so robust that they have lasted so long and have been tested now and then. Incidentally, when Toyota production system started, it was a system designed for high variety, low volume production, which is 180-degree opposite to the mass production system as we talk about. But today, what we see is Toyota producing 10 million cars a year. It is no more high variety, low volume production, but we still call it Toyota production system. Why would that be the case? Is it okay if somebody says the volume is a bit less? Am I now audible?
Yeah, you're absolutely audible, Shishir.
1.1. I just saw somebody type, the volume. So coming back, so what we are seeing Toyota do or achieve is not fashion because it's lasted so many years. And why does it keep emphasizing on the principles is the second question we ask ourselves. And today, what I'm trying to do is I'm trying to pick up what Toyota has asked the future to be like and why it has asked it to be like. And then with that, I will try and cement the past and the present together. That means why they say why they are doing what they're going to do in the future and how they're going to do. How does it sit on the same basics that was started off in, you can say, early 70s? Okay. So with that, I would like to start our biggest aid in such seminars like our uh, PPTs. Just a minute. Let me see which one is this. Okay, this one. Okay. Can everybody see this? Ashish?
Yes, yes, we can see.
Okay. Okay. Sorry. I've really gone to the end of the PPT, so I'll just quickly jump to the top. Yeah, that's it. Okay. So today's session is called Practice of Lean and Toyota Production Systems or System. And that's my name and address. And somebody wants to note down because very often I get asked, sir, can we have the email and phone number? You already have able team which can guide you through everything, but here is a small slide. What happened? Uh, I need to tell you a story that we had a poster boy in Toyota Production System or Toyota as a company for as long as 2008. In 2008, when the company made its first loss, everybody was shaken. Why did it make its first loss? You can blame it on the economic environment of 2008 when we had the financial meltdown. However, Toyota Production System was designed to actually understand and adjust itself if the economic situation was not doing well. So Toyota went into a huddle and they decided to relook at themselves that why did they make that big a loss. And by 2012, 2013, they came back with a concept that they have understood what went wrong. And then the chief of Toyota had only few words to say. Okay, he said, we are now going to go back and start working on basics. However, by 2018, they were able to complete the exercise of what needs to be done, and they published it in their annual report. I think that can be accessed anywhere on the net. And I'm depending a lot on that annual report. Now, in 2008, all the great people of lean production system or lean, whether it is James Womack or Daniel T. Jones, everybody took to mic and said that we have lost our poster boy. However, there is no doubt that Toyota is going to bounce back. Now, why did they say that? And it was very clearly articulated by James Womack saying that Toyota's production system is the result of the thinking that is called lean thinking or the thinking behind Toyota production system. And that thinking is so robust and it is so sound, okay, that he even joked that the current lean enterprise research center in California, in the US, sits across a management school. And we know that we have put a, you know, bullseye on the management institute. So we want to shoot them down. Why? Because all their teaching in management is not effective enough. And Toyota production system is that effective enough. So the reason why these people were so strong in their faith that Toyota is going to recover is they knew that the thinking behind the Toyota production system was so robust that it will create, modify the Toyota production system again. So Toyota production system keeps evolving, changing, etc., etc. But the practice of lean or lean thinking does not. Okay, it is lean thinking that leads to a production system. And Toyota's mindsets today are probably the biggest inheritance that the old generation wants to leave for the current generation. You'll see all this in the reports here there, but this is a prelude. So today what I'm trying to bring to your notice is sort of raising a question that what and why Toyota is doing what it's doing today. Then I will go back to what the fundamentals of Toyota production systems were and shall remain also in the future. What you read here is something which is what I've seen or what I heard in 1999, 2000. Why do I say that? That any theory that one propagates that this is what the future is going to be like, it should be a normal habit that when we reach that time in future, we check what exactly happened. So in 2000, there was a very nice creation or thinking process which went like this, that things are going to change and blah, 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 blah. But what is going to change or what is the future going to be like was sort of mentioned like this. I'll read it out. The left hemisphere of the brain is logical, linear, and sequential. It works like a computer. The right side is holistic, artistic, and big picture. Of course, we use both sides of a brain for most things, but the sort of abilities, characteristics of left hemisphere are becoming less valuable. This is the onset of the computer age. We predicted that it's going to be, computers are going to take over all logical, linear, and sequential jobs. 2000 was the year when this came out. So by 2020, we were supposed to see it. Today, we are sitting on another modified thing called Industry 4.0 for people like us. And we keep saying that AI will take it over, AI will take it over. But the question is, how will it take over? And where should you put your computerization efforts? If that is the aim, okay, sorry, the same thing. If that is what was predicted, there have to be a set of new competencies. And again, this is year 2000 that we are talking. The ability to think in terms of systems and knowing how to lead systems will be the new competencies required for the future. The ability to understand the variability of work in planning and problem solving. Another amazing thing. Understanding people and why they behave as they do. And the fourth competency that we predicted that time should be the core of anybody trying to seek or improve jobs in the future would be understanding the interaction and interdependence between systems, variability, learning, and human behavior, knowing how each affects others. In other words, we were saying that future is of a system as a whole, not as its parts. This is nothing but it's got a scientific basis to it. There's a theory of learning. And David Kolb defined his theory as learning is a process whereby knowledge is created through transformation of experience. Watch my word. Learning is the process whereby knowledge is created through transformation of experience. Another backbone of Toyota production system, what we normally see as Kaizen, where you have to constantly transform your experience into knowledge, and that knowledge makes the future better. Now, what exactly Kolb is trying to say is in this picture. There are two continuums, one in green going from top to bottom and one in blue going from left to right. The one going from top to bottom is called perception continuum. And the one going from left to right is called processing continuum. So what is a perception continuum? It is how we think about things. And processing continuum is how we do things. When we are trying to say that we have to create knowledge, we are making sure that we are constantly on the outer circle going and touching all the four stations. That is feeling, watching, thinking, doing. If we don't go in this circle, we don't create knowledge. That means if we have to transform our experiences into knowledge, we need to touch all these things. You would ask, why am I putting this to you today? The idea is if Toyota production system has lasted 50 years and is still going strong, it is very, very clear that they are converting their experiences into knowledge and then putting down to work. Okay, in other words, they are making sure that the knowledge they create is constantly being perfected. You may say that you can put AI and get it. AI doesn't create knowledge. It is very, very good for repeating or doing a work for which they have a database on. What the future is going to be, what is the idea of perfection? Can AI tell you that? No. So whatever may be the system, it is very, very clear that Toyota has imbibed in its very root the process of ongoing improvement and creating knowledge by transforming their experiences. I'm using the help of this to just say that Toyota production system is not born out of out of isolation, and it's only that the Japanese can do it and things like that. However, the culture is the one that drives us to decipher, understand, and learn how they learn. And such small, you can say, formulas or presentations do tell us that we can identify the state and we know what the next state is going to be. Okay. Now, this is a small debrief, but the reason why I'm putting this is you will see that sometimes to tie all the 5, 6, 7 comments that the top Toyota people are doing, or many times we hear, we don't have a hypothesis or we don't have a theory that is going to tie all of it together. So we can say that all these behaviors and reactions and tools and techniques and management concepts are born out of the same thinking process, right? That is why I'm taking help of this tool. There's enough you can do. You can get yourself tested. What learning style do you have, and develop many things. Okay. Let me come back to Toyota. This is Moritaka Yoshida, Executive Vice President, Toyota. In 2018, when they had developed and put their plan for Toyota's future into action, they came out and they spoke what the future is going to be like and what we are going to do in the future. From 2008, when they made a loss, to 2018, it's taken them 10 years to be sure what the future is going to be like and what Toyota production system or Toyota should be doing in the future. Yes, they talked about a connected vehicle and they talked about so many things in the future where they're going to depend on cross-functional dependence. I'm not touching anything of that. Because yes, if the society needs connected vehicle, that needs to be put in place. So they have decided to work together with many other departments or outside the world for sustainability, as well as making sure that they do more with less resources by collaboration. However, the focus of today is what they said about Toyota production system. So these are the 4 points I picked out from his speech. The Toyota production system is a system for completely eliminating overburden and waste to improve productivity within flow of things and people. These are exactly his words. Where do we see in this Toyota that we have to create a low cost system? However, by eliminating overburden and waste, you are having the least cost production system. And mind you, at this point in time, by 2016 and 2017, people had started talking about Toyota vehicles being expensive. So the value proposition that we talked about for so long, that let us do value stream mapping and let's remove waste and increase value, had stopped working by 2008, 2009. So it was very, very clear to the vice presidents or the president of Toyota that we are not doing the basics right. Number two. So the first operating word here is overburden and waste, and within flow of things and people, right? Number 2 point. Until now, Toyota production system has been applied mainly at production sites, where it has been refined and developed through many years of use. Now, we are introducing the principles of TPS at development and manufacturing technology units. What do we read from this? That the current Toyota production system has got the same principles as we started off on, but they have been refined, modified, and adjusted or developed through the years of use. That means the knowledge kept improving the Toyota production system. And mind you, it is not Kaizen only. Though Kaizen is the concept which forced them to improve, but Toyota production system has improved, changed, morphed. And that is the tools I'm talking about, not the concepts. Concepts remain same, tools keep changing. And why do the tools keep changing? Because they have to constantly make sure that they're eliminating overburden and waste. One of the motivations behind this move is our strong desire to develop our human resources in these units by having them apply Ginchi Ginbatsu, on-site hands-on experience, to think about the cars they are working on and the entire process from development to production preparation. If you notice something, he has used a word called production preparation in the third point, and in the second point, he used a word called manufacturing technology. Okay, we shall come on these two again. But please understand that what is the future of Toyota production system or the present of Toyota production system has to be understood, that what are they trying to achieve with this? Why are you sending people on the shop floor? Because by now, whole of Toyota shop floor should be automated. Robots should be doing all the work. At least that is what we said in 2000, if I remember most of the people. And by 2020, we are spending crores and crores on Industry 4.0, right? And there's so much of focus on Industry 4.0, but yet not on product development. I still don't know why should you spend more money on automating a shop floor, which is doing repetitive, discrete manufacturing, and you should not spend money on developing a new product. Because if you don't spend money on new product development, you are moving away from the value that the customer sees in your product. Forget the waste in your manufacturing system. Anyway, so the motivation is also there, that we want to make sure that people are sent to the shop floor. Why are they sent to the shop floor? Maybe we'll talk about it a bit later. But what is the final thing he says? He says, by doing so, we hope that we will learn to completely eliminate waste. So for 50 years, they've been trying to eliminate waste. They have not eliminated it yet. However, now in the future, they think when they combine manufacturing and development together, they will be able to eliminate waste. One question I can ask most of the participants. So how many times Toyota would have done value stream mapping in their company? Or in other words, how many times do our companies do value stream mapping? How many times our companies update the data of production cycle? I have yet to come across a company which does it every 3 years also. Once done, they leave it. So just imagine that value stream mapping is done, has been done in Toyota on a continuous process. And we have a value stream manager as a rank. Okay. So this is what the executive vice president of Toyota said. This is practically, he said that this is how we're going to work in future. Okay. He said this is a work process. One team uniting 4 functions. One team uniting 4 functions. And watch the top, is a decision making by in-house company presidents. Again, I'll bring your notice to the 4 yellow boxes: design, production engineering, manufacturing, and planning. This is the cycle that makes any system. Okay. And just imagine, when we are focusing on reducing waste, a lot of waste is getting developed or has been created between design and production engineering and manufacturing. Why we have production engineering and manufacturing separate is a question you can ask yourself. And if you're using it interchangeably, you are way off the target. This is what Toyota production system today is. They have understood design is separate from production engineering from manufacturing, and manufacturing from planning. And planning is the management part. This is what the president said, that we are going to make sure that we have everything integrated in the Toyota production system. And mind you, not a single place has he talked that we will do 5S better, we will remove Muda, okay, or we will do TPM better or we will do OEE better. Okay. Why? Because they are not part of the system design. They are tools which are required to make sure that the objectives of Toyota Production System are met. That is, no overburden and no waste. He is also defined the TPS at the core of corporate management. And this is the slide he has used. He said Toyota Production System has got two pillars right now. Right now, not has been also, Jidoka and just in time. Mind you, these two pillars have been existing in the Toyota Production System forever. This is the place where he says that we can go back. And if these two systems or these two pillars have been existing in the Toyota Production System for so long, they are robust. So Jidoka, that is automation with a human touch. Quality must be built in during the manufacturing process and not the production engineering process. Watch the word here. We have already separated production engineering from manufacturing process. Plus, just in time, making or transporting only what is needed, when it is needed, and in the amount needed. It's not only inbound logistics, it is not only within the factory logistics, it is right up to the place when the customer buys it. That is why making or transporting are the two driving in factors which drove Toyota Production Company to a loss because they were stuck with huge inventories. Though inventories on a balance sheet turned out to be profit, so they were suffering from bigger issues than just inventories. But huge inventories was the problem in 2008. And when you combine both of them, cost reduction through the complete elimination of waste. So you are not focusing on cost reduction, you are focusing on elimination of waste that will lead to cost reduction. And please do not take it any other way. You cannot focus on cost reduction. Cost reduction is a measurement of elimination of waste. This is what in 2018 he said the future of Toyota Production System is going to be. Does it look any different from the past? Not this slide. This does. Because we as a practitioner of lean have yet not been able to integrate this much. And mind you, it is a process of ongoing improvement. The arrow keeps going round and round, round and round. Okay. So if we have not done it, we still have not milked the whole concept of lean. This is, you can say, the Toyota Production System or corporate management. Within the corporate management, the focus has always remained that we want our people to go to the shop floor. So this is, you can say, the another executive vice president, Mitsuru Kawai, and he is from the HR side. Or you can say he's from the manufacturing engineering side. Because very, very rarely they have a HR department in, in any of these companies. But his one line in the 2018 report is, only by applying human wisdom and skill can we realize the evolution of machines. That is why I would like to nurture our people. This is the future of Toyota Production System. The wisdom and skills. And that is why I tried to show you the first slide where I said that the future competencies are going to be thinking as a whole. And what are the skill sets? Skill is nothing but you should be able to train yourself to do something in the perfect way. In other words, if you're making a, let's say, a cup, if you cannot make a cup with your bare hands and show that this is the perfect type of cup I want, you cannot even develop a manufacturing process for it. You cannot design the production system for it. You cannot do production engineering. What machine should you use? How to use it? Okay. Then while manufacturing, the workers may not know how to use that machine. And hence, you are not able to convert your human wisdom or the knowledge that you've gained into a production system, sorry, a manufacturing system. And hence, there is no improvement. Yes, you can do 5S, you can do ppm, but they don't add to the bottom line as much as making sure that the customer buys your product on time with the least amount of human effort and least amount of inventory. It is cash flow that runs, not assets. So Toyota production system from the word go was designed for a cash flow system, and the future doesn't look much different. They have talked about evolution, they've talked about everything, but they have still said it is only with the human being's wisdom and skill can we ask the machine to evolve. What does it say? Creating by hand, the foundation of engineering skill. Where is the automation here? Okay. Where is the future that everything will be done by the machines? The foundation of engineering skill, building production lines by hand first. Learn the basic principles of manufacturing, apply them on site. How do you apply them? How do you accumulate? Yes, you got to do Kaizen, you got to do constant improvement, you got to apply science, craftsmanship. So accumulation of Kaizen should be converted into craftsmanship. That's nothing but skills, human skills. Convert that into a jidoka. That means make sure that you are able to put human angles to machines, when to stop, when not to produce a wrong thing, and how to make sure the wrong thing doesn't get fed inside it. And the other word that you're seeing here is karakuri, which is nothing but not every work is done by machines. So jidoka applies to machines and karakuri applies to other other sources where energy is not used. So there is a clarity that what you're going to improve, how are you going to improve? And this is the future of Toyota production system we're talking about. We're not talking about the past. We're not talking about the present. In 2018, they're expressing what the future of Toyota production system is going to be. And still, it's got so much of human touch inside it that only can reduce waste. Another example, he says, human skill, craftsmanship is necessary to teach the robot to write beautifully. This is an example. There's a human being with no calligraphy experience and a robot with no calligraphy experience. But a human being with calligraphy experience writes it so beautifully, which is far better. And then he's able to teach the robot, but the robot still cannot do as good as the human being, but very close. The essential difference you will see is in robots writing and human writing, the thickness, thinness, and flow are different. But only after a human being has been taught calligraphy can he teach the robot to write properly. So whether you're making intricate things, curvatures, and etc., human beings, their skills can only be perfected and then taught to robots. So straight away jumping to robots for efficiency or automation in the name of Industry 4.0 doesn't work. They've already learned it, and now they're also predicting it for the future. So what they've decided that this is going to be our virtuous cycle. On one side is skill, the second side is technology. Okay, and it's going to be constantly evolving upwards, which is nothing but again doing Kaizen constantly to make sure that we learn and teach the technology. So on one side is skill, the second side is technology. Craftsmanship. What is technology? Digitization, automation, mass production. And they are going to make sure that they create manufacturing technologies and manufacturing methods that are going to reduce waste. At this point in time, I would like to bring into our mindsets, the idea of Industry 4.0. By putting the Industry 4.0 sensors and etc., what waste are you removing? In fact, you're only getting sensors back. You're creating waste by putting a machine which is not adding any value to the system. And if you're putting a robot to do work, okay, yes, it's doing it faster and you think it's cheaper, but maybe it's still doing so much of waste. And hence, the thinking of Toyota Production System has in itself a corrective action. And the corrective action is that human skills have to perfect and teach that to robots. Not that whatever robot is doing, it's called cheaper, faster, and we have automated it, so we are better. They have never gone for automation all the way from early 80s. They've always fought the robotics issue, but they have made sure. So this is what I say is the present as well as the future of Toyota Production System. We have not talked about tools. Yes, there will be new tools available for us. Today we are measuring, today we are doing sampling. Maybe the computer will stop itself when it produces a rejection. What is the use of keeping upper limit, lower limit control systems? When it produces a reject, it stops. Where is the control chart required? So what we are seeing here is Toyota is still looking to eliminate waste and not automate simply. Technology and skill will work hand in hand to create manufacturing methods and technologies. Create manufacturing technologies. So you please see that what we are talking about, Muda on the shop floor, inspection, weight, anything, constantly being removed and it's been taken back to the design stage. So the design, production engineering, manufacturing, and planning, and back to design. So what they are saying is that every time we see a waste being produced, whether in manufacturing process or production process, we take it back to design and eliminate it. Not all manufacturing related processes can be eliminated on the shop floor. So why did we stop? And hence they created better manufacturing technologies. This is what they are saying, that we will take TPS now to the manufacturing technology area. By now you would have seen that Toyota had already thought about so many things. It's already made a statement in 2018 that this is the future of Toyota. That means I'm not talking about what Toyota will do, but what Toyota Production Systems will do. Okay, they will go everywhere. However, within the Toyota production system or manufacturing process, they will make sure that the people are still skilled. That means blind automation is not required. This finally brings me to a point where in 2014 or 13, the president of Toyota said that we have decided to reinvent Toyota production system. And we are going to re-engineer the whole system and it's going to be done by only these 7 words. Going back to basics, forwards, making exciting cars. Second, these were the 2, you can say, lines or statements used by Toyota's president way back in 2011 or 12 when he said that we have learned from the fiasco of 2008 and this is what the future of Toyota is going to be. This is what we are going to reinvent ourselves. And we will reinvent ourselves by going back to basics and making exciting cars. Before this slide, all I showed you was what Toyota has decided and publicly come out to say that they will 2018. The state of Toyota production system today is not one, but many, but all of them are still saying that the future is going to depend on removing waste. How do we remove waste? We are going to make sure that from design to planning, the whole circle is run. And this whole circle is run in 4 stages: design, production engineering, manufacturing, and planning. This is how Toyota's basics were and shall remain. Making exciting cars, definitely. This was a big part because Toyota cars were being seen as expensive from the customer's point of view. That means the value proposition was going down. You can make a very nice Prius, you can make a connected car, you can make a hydrogen car, but if the customer doesn't see value in the product, he's not going to buy it. And lean is about adding value to the product, not by design, but by production and manufacturing. Okay. So this is what they meant. Now, if they said, let's go back to basics, why don't we also go back to basics and see what Toyota Production System did? And why has our use of the practice of lean for so long has stagnated? Why have our companies not consistently grown so fast or yielded much more than they should have? I'm talking about our manufacturing companies. For that matter, Toyota in India is also struggling. It is not out of the woods yet. How come Toyota in India is still struggling? Many of the companies that we see in manufacturing, Honda also is like shaky many times. Maruti has a very dominant position in the market, so we don't get to see the full impact of its inefficiencies. But still, the practice of lean, I'm not talking about Toyota Production System, the practice of lean as understood by us is still not matured in our companies. We might think of using very standard process and repeating it again and again and trying to maintain the current system, but very few of us have actually built our manufacturing systems on lean. Let me go back, rather go front and take you to the next slide. I've talked about basic fundamentals of lean. So what are these basics? Probably many of you would have seen this simple diagram, okay, of the Toyota Production System. And lean is an offshoot of, not offshoot, rather a English interpretation of the Toyota Production System. And I thought that going back to basics could nothing be more powerful than this diagram. So there's a whole Toyota Production System as a house gets very clearly answered in this diagram. What is the goal? Very, very clear. The goal is highest quality, lowest cost, and shortest lead time. Okay. All these three goals run together. You cannot say that I've made the least cost product. So when they chose these three goals long ago, they were perpetual. What is highest quality? Naturally, the product design keeps changing, the customer expectation keeps changing, what the product's supposed to do keeps changing. Okay. The performance keeps changing. So quality is not only rejection. Quality was defined as from the customer's point of view. The goal is this, and the lowest cost, not cheap. The word is not cheap. Lowest cost. So highest quality at the lowest cost and the shortest lead time. To support these goals or the roof of this house, there were two pillars, just in time, Jidoka. And to your surprise and to my surprise, they still are the same two pillars. And they've decided that these two pillars shall remain even in the future of Toyota Production System. They've got them 50 years, they should take them another 30 years. Because the plan which I've just put to you is for 2050. Okay, so it should take them another 30 years. These pillars, two pillars, have got certain necessary conditions. Continuous flow, takt time, and pull system. The principles on which JET or just in time is designed is continuous flow, takt time, and pull system. That means it doesn't like batching. However, it also doesn't like a constant rate of output. It says that just because you have to make in just in time, you cannot keep manufacturing at the same rate of production. The rate of production has to change. And how do you know when you have to change? That is governed by the takt time. So by design, your production lines should be flexible. Okay. And you will only produce when upstream or when downstream line wants. So finally, you'll only produce to demand. And this is what Toyota didn't do in 2008. They started predicting and trying to make sure that they become number one in the world and the largest producers, and hence they lost focus on the top goal of their organization: highest quality, lowest cost, and shortest lead time. They wanted to become the world's number one. World's number one in what? Naturally, the maximum number of cars. So pull system failed. Why? Because they were producing as much as they could produce rather than what the demand wanted them to pull. So just in time has got three fundamental principles, not tools and techniques, principles. Similarly, Jidoka, which was the first thing and probably designed in 1940s, not even 1960s, okay, has got two principles: stop and notify of abnormalities, not rejections, abnormalities. Separate human work and machine work. Very, very clear. Why do we do this? So the worker can handle multiple machines. When do you separate human work from machine work? This is where you start moving into a zone where you are making sure that high skilled work is done by humans and repetitive work, loading everything is done by machine. Why do we need machine there? Very clear that we have now perfected the process. It needs to work at high speed. Why do we need human there? Naturally, to make the machine work. But you cannot have one time in so many companies, or rather in all the companies that I've gone till now. When I ask them about the cycle time, they have only one cycle time. So the machine cuts from here to here in 15 seconds. From loading, cutting to offloading, 15 seconds. How are you separating machine work from human work? If you do not separate machine work from human work, how do you make sure that you can be productive? How do you know you're going to design a machine where a man can handle more than one machine? But watch it. If the takt time is changing left, right, that means going from minimum to maximum, it can happen that the human person required to be present to make the machine work might be more when the rate of output is more and less when the output is less. So both the number of machines that a human being can work and the time that he spends will vary depending on the takt time. So by design, we have to make sure that we adjust both human and machine. And this is what Jidoka did and focuses you to do. However, both these pillars are on foundation, and the foundation is in two layers. The upper foundation consists of Haijunka, standardized work, and Kaizen. Okay. Haijunka, standardized work, and Kaizen. So should you not have these three things as a foundation, it's quite unlikely that you have even started working on lean. You can be using a tool of lean, and most of the times I see very fancy tools of lean being used, but very rarely have I seen Haijunka and standardized work being followed, improved upon, etc., etc., by the Kaizen mentality. Most of the Kaizens that we see people working on the shop floor Kaizens. Okay. But if Kaizen is not the backbone of Haijunka and standardized work, you are not improving the overall system. That means the foundation itself is weak. This is the upper foundation I talked about. But the most important foundation is the lower foundation on which the whole house rests, and that foundation is of stability. And this is where the science of Toyota Production System comes into play. It is variability that kills the throughput of the system. So the first idea is that you're going to make sure that you look at the whole variability of the system and make sure that you constantly keep reducing the variability before you can get into Haijunka, standardized work, etc., etc. It comes much later. But if the variability in the system is very high, it is quite unlikely that lean can be applied with full effectiveness. Doesn't it sound very similar to what 2018 Toyota people have talked about? That in the future we're going to go this way. But this is also what has been happening for last 50 years. Just to spool back, this is what I said. I said the concept and the principles are so strong that new tools, in other words, production methods and manufacturing methods, can be brought into use because these principles of lean allow you to do that. Rather, they force you to do that. So you keep improving, not get stuck on it. It sounds very simple in the name of takt time. Okay. For example, let me go still down. Standardized work. It is a constant process of improvement. How are you going to do it? It is a scientific process. It requires people to think, develop wisdom, and then standardize. Let's go ahead. So we talked about a very stable environment. Why? In this diagram, and it's not my diagram, okay? It is from the Lean Lexicon book or the Toyota production system. So what it requires is stability, the lower foundation. TPS demands stable production environment. That the processes and the products, what does it mean by being stable? Okay, I'm just going one level down. On top the stability, but what does stable mean? The process and the products should not change significantly for a considerable length of time. Second aspect of the stability required by Toyota production system is stability in demand over time per product. Okay, that means every product cannot have a high fluctuation in demand. Why does it not have a why should not have a fluctuation in demand? Because naturally they are making so many products on the same line that the load coming will vary. The third assumption or the third requirement of the stability is the most demanding aspect of the stability required by TPS is stability in the total load placed by the orders on various types of resources. So when we talk about stability, these three conditions have to be met. Now, how you make it meet is the trick and the mindsets that the management system uses. And hence, we have the birth of Hyjunka and standardized work. That we are going to create processes, we are going to create sequences, we are going to create sequencing in production so that for every half an hour or every 1 hour, the output remains same. That means load leveling. And it is not by making sure that I produce 5 items of the same type. No, they do product mixing because that is the need of the takt time and sequence the product in such a way that the average load on machine for every half an hour or 1 hour remains constant. A unique feature of TPS, it requires very less management intervention for operation. And then they say that Toyota workers come to plant not to work, but to think. And there's a clear distinction between manufacturing design and production design. I have touched upon this in the current system as it is. And this slide is from the old system. So 2018, still they are very, very clear in saying that manufacturing design and production design or product engineering and manufacturing engineering are two different issues. Toyota has standardized work because it it believes in the system output as a whole, not as a local optima. So when we are looking at a system as a whole, we move from efficiency to effectiveness. And that is why they've defined two clear words, value and waste. Many people say, let's create value by removing waste. Okay. But more so, when we remove waste, we reduce cost of operations. And when we improve value, we make sure that the demand goes up. So there are two different words. And if one is able to, or one gets confused in both of them, it is another sign there where the principles of the Toyota production system were not properly followed. What is the waste? Any activity that consumes resources but creates no value for customer. Most activities are waste. That is muda. And they fall into two, type 1, type 2, something you can get rid of, something you have to live with. So please understand, when we say removal of waste, we are also pushing it to the design part, right? And if you have not taken it to the design part, that means you have to live with it. For example, the manufacturing process of painting. You need to check it visually. You need to go repaint it. It's got a lot of waste. Rework is there in painting. So we are supposed to create a production method where such waste can be removed. What is value? The inherent worth of a product as judged by the customer and reflected in its selling price and market demand. The value is a typical product in a typical product is created by the producer through a combination of actions, some of which produce value as perceived by the customers and some of which are merely necessary given the current configuration of design and production process. Okay. So what are you doing in value stream mapping? Are you creating value or you're mapping waste? You are mapping waste. But like we get confused between cost and expense, okay, we are confused between value and waste. Okay. But value is in the eyes of the customer, not you. So value creating, what is value creating and not value creating? Any activity that a customer judges a value. A simple test as to whether a task and its time is value creating is to ask if the customer would judge a product less valuable if this task could be left out without affecting the product. For example, rework and queue time are unlikely to be judged of any value by customers, while actual design and fabrication steps are. Okay. So value stream mapping, okay, cannot be only done on the shop floor because value is technically created at the design. That is where you build in features. And finally, when you create those features on the shop floor, you are creating value. So what is Muda? Okay. And we still have not been able to remove Muda. This is how you can say how slow our progress of practice of lean is. So should you be practicing lean, you should be constantly making sure that the mudas and the muras and the muris are being removed. So the first step to do is recognize and quantify both value and waste. Great value creation is done through the product and process design. Great waste reduction is done by good production system design. Okay. So value and waste both are different processes and they feed each other. I talked about Muri, Mura, Muda. Many of you must have seen about it, but this is what we're talking about. We are now in, if I recall what the president of Toyota said, the Toyota production system is trying to remove overburden and waste. So he mentioned Muri and Mura, but why, sorry, Muri and Muda. But why didn't he mention Mura? Because the basic assumption of Toyota production system is stability, right? And that is unevenness. And he also knows that Mura leads to Muri leads to Muda. Okay. So if we remove variability, we are reducing overloading, overburden, and then that is leading to waste. They may be linked together, but when you start attacking and understanding where you're going to work first, you better well know that Mura leads to Muri leads to Muda. And he's talked about Muri and Muda. Again, it is the principles of flow which use a set of tools to create a system. That means whatever we are trying to do, stability, Haijunka, this, Jidoka, just in time, etc., are nothing but principles of flow, which again has been mentioned by the Toyota production system within the flow of people and material. So we use a set of tools, okay, to create a production system, but we measure the production system through effectiveness, not through efficiency. These are the principles of lean. Everybody knows 7 wastes. Okay. But when I start thinking, or when I ask people which is the worst amongst all of it, okay, I find people say, sir, I think, correction or rejection is big one. Okay. Or inventory is really bad. Okay. Or, waiting time is very bad. Many people also say overproduction. The next question that follows is, why is overproduction bad? And we are still on Muda, not on Muri or Mura. Why is overproduction bad? Very simply, overproduction is the cause of the rest 6 of the waste. Now, this is why JIT is forcing you to produce only what is required in time. Because if you are making sure that you do not overproduce, you are indirectly already impacting part of the rest 6 of the wastes. These are principles. You can classify them, but you cannot say that they're not interrelated. And we have tools for all of it. Overproduction, how do you control overproduction? Naturally, you have to implement Kanban. For the rest, there are tools available. So practice of all these tools still does not mean lean. Using only one of the tools does not mean lean. You can do 5S, you can do statistical process control, you can do a single piece flow, you can do a bit of TPM, and you say you're doing lean? No. If you say you're doing lean, you are doing lean only and only if you're working on all the 7 mudas, or you are working on Muda, Muri, and Mura. And the cycle keeps going on. These have been the principles of lean forever. Beyond the slides where I pulled out from what the 2018 vision statement of Toyota would be, all these slides are old lean system slides. So for Muda, we have 7 tools. What about Muri and Mura? Okay. So we come to the second tool called Haijunka. In Japanese, the word Haijunka means roughly levelization. Leveling the type and quantity of production over a fixed period of time. This enables production to efficiently meet customer demands while avoiding batching and results in minimum inventories, capital costs, manpower, and production lead time through the whole value stream. So if you do not do Haijunka, that is the upper level of the foundation, you actually are not planning and sequencing the product correct. And if you're not planning and sequencing the product correct, you are making sure that Mura or Muri is in play because there is an overload taking place in the system. There is a fluctuation of load. So leveling of load doesn't mean that you level the cycle time. You do the product mixing in such a way that the average load for a period remains constant over the time of production. But you also have takt time in play, where the rate of output is going to vary. So how do you know that the cycle time can vary? And this is where the second part of standardized work process comes into play. And this is where you sometimes, for a higher rate of output, you need to add manpower, you need to reduce manpower. And this can only be done if you do Haijunka first. If you come out of the lean production system, okay, we have been talking about demand-driven manufacturing and etc., etc. All that is based on science of standardized work as well as Haijunka. You need to know. And when you're doing Haijunka, there are 2 parts. One is the manpower, the second is the machine. So your load may come evenly on the production cycle or the machines, but it may be uneven on the workman. Both of these need to be done together. And based on this, you decide whether there's going to be a U-cell layout or a straight line layout. So if you just decide U line is very good and you start running a U line, again, you're making a mistake in practice of lean. So to look at Muri and Mura, you need to do Haijunka first. Let's come to the second pillar. This is of lean. I talked a lot about JIT. Let's come to Jidoka, providing machines and operators the ability to detect when an abnormal condition has occurred and immediately stop work. This enables operations to build in quality at each process and to separate men and machine for more efficient work. Please be very, very clear what this one is talking about. Jidoka, many people say it is with human ability. That means to stop work. Okay. Enable operators to build in quality at the process. That means you don't produce waste. Okay. Abnormal conditions occur. So Jidoka highlights the causes of the problems because work stops immediately when a problem first occurs. Please go back to what they said. If the human interface is not there, how do you develop wisdom and skills? So when the machine stops at the problem it has created and the worker is there, he goes and sees what type of problem has been created, what has happened, and he develops his knowledge. And you develop knowledge by transformation of your experience. In other words, you start trying to focus on what Kaizen can be done. Jidoka sometimes is called automation, meaning automation with human intelligence. This is because it gives equipment the ability to distinguish good parts from bad parts without being monitored by an operator. Right? So the idea is with the human skill, you'll keep developing systems simple, so that the human being is not required. That doesn't mean robot. With the same old machine, whatever process is doing, okay, the operator is required less and less, and hence operator can handle separate machines. The other scientific work which I was talking about is standardized work, right? The upper level of the foundation. What is standardized work? And should you not have this in place, please understand that all the practice of lean tools that you are using have limited effect. Standardized work, establishing precise procedures for each operator's work in a production process based on three elements. Takt time, which is the rate at which the products must be, takt time, which is the rate at which products must be made in a process to meet customer demand, right? So takt time can fluctuate, right? So if the takt time can fluctuate, you should be able, okay, to calculate, okay, what output rate can the machine go up and how much it can accommodate and etc. etc. So what is the lowest mode takt time? What is the highest mode takt time? Beyond which you'll need to do a change. That means you need to change the process a bit. Second, the precise work sequence in which an operator performs tasks within takt time. Okay. So first is you may have different sequences of operations depending on the takt time. But for whatever takt time you have chosen or you fall into, you are very clear about the sequence in which the operator will perform the job. Now, having chosen both of them, the third is what is the minimum inventory that should be present to make sure that the operation doesn't stop. The standard inventory, including units in machine, required to keep the process operating smoothly. Right? I am pretty surprised with the third point myself. And every time I've read it, I've tried to understand that when did I last see this? Nobody talks about it. But this is what forces us to develop 5S standards. Okay. But very rarely we know what is the minimum inventory that should be present so that the work keeps flowing. Now, manufacturing process can be made of 7 to 8 standards. Right? So now if a guy is working on 3 to 4 machines, okay, you have to make sure that the inventory levels on each machine are so that even though he might be busy on another machine, one machine doesn't stop. So you have to make sure that the standard inventory levels are present. And how many of us can do this is my second question to myself. But yes, I am very convinced that during my processes, I have never seen a thorough standardized work. Yes, sequence can be told, but at what rate of output, we do not know. We never talked about takt time on machines, and we never knew what the standards will be. So when we come to the upper level of the foundation itself, on which tools and techniques were developed, we realize that the two parts, Haijunka and standardized work, okay, are the big missing link. Doing one of the three aspects of takt time, that is precise work sequence in which an operator performs task within a takt time, is all that we have done. When he should stop, how much time he should take to come out, we never bothered. So now the process is this standardized work is the place where Kaizen is worked upon day in and day out. Okay. So how do you do Kaizen? In standardized work, you try and reduce the minimum inventory levels to sustain the flow. Okay. So either machine will become a constraint, either the changeover time will become a constraint, etc., etc. Okay. So standardized work is the engineering background where we keep doing experiments and we keep coming with data which can help us increase the rate of flow, which is nothing but reducing waste and overburden. Standardized work, Haijunka and Kaizen, the foundation of the lean. And yes, the two pillars will remain same. They'll remain just in time and remain Jidoka, whatever level of automation we may go to. So the principles of lean have remained same, and these are what we call the principles. Rest, all of them are called tools. I did show you in our examples of Muda that production, waiting, convenience, processing, inventory, motion, correction. If these are the 7 waste as classified by Mr. Taichi Ono, the tools are available. But you don't design a production system based on tools. You design production systems based on lean principles. And the lean principles are written in the basic foundation. That means you're going to make sure that you're going to avoid overburden, you're going to reduce variability. That means you have to induce stability. And the third thing is you're going to constantly remove waste. How do you remove waste is the final question I will talk about. So if overproduction, waiting time, conveyance, processing time, inventory, motion, okay, these are the 7 wastes and they all come into Muda. So what is the unit of measurement of Muda? Some people may say, listen, I have reduced waiting time, so I've saved cost. How have you saved cost? I have removed reduced inventory, I've saved cost. Probably you can do some calculation. But if you remove motion, how have you saved cost? You do not know. And hence, the unit in which we try to measure the improvement of MODA is time. Anything that reduces the time between when the customer places an order on us and we collect cash. If this throughput time keeps going down, it is called improvement and also, sorry, and also a reduction of MUDA. These are the principles of lean which have remained. So the practice of lean principles should be the knowledge of lean and not the use of lean tools called as the practice of lean. With this, I finish my presentation, but not without the last slide. So the future for Toyota as given to us by the current management team of Toyota is number 1, surviving a once in a century period of profound transformation. 2, creating the mobility society of the future. So they know that we are transforming the industry and the mobility in the society has to be relooked at. However, both these things futures are still based on the Toyota production system or the fundamentals of Toyota production system, which they say they have inherited from their past seniors and would like to make sure that they understand it and leave it for the future generations to come. Okay, with this, I come out of my presentation and now we are ready to take questions.
The first question is from Mr. Venugopal.
Hmm.
Can you elaborate the specific difference between production and manufacturing?
Yeah. So production engineering. Okay, I hope it is production engineering and manufacturing. So production engineering, by example, is suppose you are going to cut sheet metal. So you will decide which scissor that you should use to cut. Okay, fine. That is the design of the production engineering. But when you start using the scissor to manufacture it, it's called manufacturing engineering. So you train the worker. You may not have the scissor that you require. Okay, you may have a scissor which is of older model. So when you start manufacturing on the shop floor, you are supposed to be skilled in using the scissors. But the selection of scissors is production engineering. Okay, and using the skill is called manufacturing. Okay.
Okay. Next question is from Mr. Tarun Kohli. Is trying to attain perfection leading to additional cost in short run?
No. No. You see, perfection is simplicity. So it is quite likely when you head towards perfection, you would have simplified the process so much that overall cost has gone down. So if you say I have improved something locally, but the others are increasing the cost, it means that you have not achieved perfection. Perfection can be judged only from the overall cost of the system, not at the local level.
Hello. Hello.
Yes.
I am RP Karmakar speaking. Sir, madam, but in case of servicing operations, that is the productions, in case of productions, you have described it. But in case of servicing job, then how we can improve? Can you say?
Servicing what? Is it servicing an automobile, servicing an engine, or just
servicing
dispersing?
in engineering? Servicing in engineering
Yeah.
department?
Yeah.
Servicing in, is it applicable or not?
Everything is applicable. If you are servicing, okay, you are supposed to understand again the same thing, that when a customer places an order on you, how quickly can you get the machine back for his use? Okay, any activity which the customer doesn't seem fit, you can enter some, let's say, let's take an example of car. Okay, my car takes half an hour to get serviced, but the guy comes and takes the car from my house in the morning and returns me in the evening. Right? He may service in half an hour. He is very busy. He says, sir, I only used half an hour, but my showroom was full. So I took your car away for a whole day. Right? That's one total time. Then within servicing, if the design is not properly done, so the vehicle can be serviced easily, the vehicle that returns after servicing is still not very good. The essential difference between Honda, Maruti and everything, Honda is super serviceable. So they've made sure that the vehicle ownership experience is also put into place. So in Toyota production system, there are usually three major pillars or three major segments of sir. One is called customer experience. The second is from order to delivery, order to cash cycle, and the third is product design. Okay, so current Toyota production system is saying that we are now going to take TPS to the connected world or the product design stage also. Okay, sir.
Okay. Next question is from Mr. Amit Kumar. What percentage of production floors jobs are automated in top manufacturing automotive companies now and in the next 3 and 5 years?
The automation of a job, if you're saying the robots are manufacturing and what robots are doing, okay, only in final assembly, when there's a top manufacturing, even a sub-component manufacturing company is called very good. Okay, So if you're talking about from the manufacturing of final assembly of a car, you can say nearly 50% of the job has been automated. Okay, but that doesn't still mean that the robot doesn't need to be trained again. Okay, but as you keep going down the transformation process where there's metal cutting, where there's still human beings involved, yes, 80% of the job in manufacturing is still done by the machine, but a human being is involved in loading, unloading, and deciding to press the button, etc. Okay, so since the old time to what we are today, if I compare 1970s to 2020, 80% of the production operation has been mechanized. That means machines are doing 80% of the production job.
Okay. Another question is from Tarun Kohli. How to ensure TPS is being followed sincerity in Indian context? Indian worker mindset is very different from that of Japanese worker.
You should, this is what makes me laugh. Okay. Why do I laugh? I'll be very, very simple. Why? Because I would like to know the difference. Don't just go ahead by saying we are very different. Okay. It doesn't yield to any action. It is not actionable. You tell me what exactly is the difference between a Japanese worker and an Indian worker. Okay. One thing is for sure, that the way the Japanese tell you what to do, what needs to be done, okay, is far more precise than us. I still have to come across an engineer. I'll give you a very simple example of a excellent engineer who went to a shop floor, was seeing a motorcycle being repaired, and there were dent marks on the fins of the engine. So he told the worker, "Why are you not doing it properly?" The worker says, "Sir, ऐसे ही होता है." So the engineer opened the engine and assembled the engine without a single dent.
Right.
Since then, the workers were doing it without a dent. Okay. Now it was a very clear example that the workers think that my boss doesn't know much, but if the boss knows much, the workers improve. And going back to the history, the Japanese, it is much tougher to train a Japanese worker than an Indian worker, because the Japanese worker thinks he knows everything. That this is a statement of Taichi Ono, not mine. Okay. So the father of Toyota Production System has said this. And he used to go onto the shop floor and slap people. So if you're slapping workers on the shop floor, for which you get thrown out of the company, you can understand that a Japanese worker mindset is nothing. No, please understand, it is the human wisdom and it's the job of the shop floor manager to make sure that the worker understands.
Okay. Next question is from CM Harbula. How to implement TPS in a food processing plant?
Implementing TPM, the two aims you have to achieve in a food processing plant. The first is to make sure that you only produce what needs to be produced and try and keep reducing the batch size to 1. As you keep reducing batch size to 1, you will see that the time it takes for you, because you are a perishable, watch my word, you're a perishable. Okay. So the time it takes for you to buy a material and convert it into a packaged good will go down. So your simple aim of implementing TPS is to make sure that when the item arrives in your shop floor, it gets packed, has to keep going down. You measure it. Then anything that stops the usage, that means batch size, you're buying in tons, you start buying in kgs. You're buying once a month, start buying every day. Okay. Then you buy only that can be directly sent to the shop floor. You start doing quality inspection in a way that the material doesn't stop. This is how the TPS gets implemented. So you will make sure that anything that doesn't reduce the time between when the raw material arrives in your factory and gets packed, okay, you keep reducing it, it is TPS. Okay, principles of lean apply.
Next question is from Anand Bhagwat. In current scenario of war, COVID, many uncertainty, how JIT be possible? Global impact for smooth supply of RM is major issue. Please suggest.
Yes, it is very, very simple that if there is a lack of supply of raw material, the production line should stop. Okay. Now, if you are saying that you don't want to stop the production line and keep manufacturing, and naturally there's a disruption. So number one, you're talking about the lower foundation of the production system, right? you are not talking about the tools and techniques of the Toyota Production System. You're talking about the lower foundation, which is called stability. Like I said, that the variability has to go down. The variability means availability has to be consistent. Now, in an environment where your raw material is not coming in, okay, you cannot do much by implementing JIT, because the purpose of implementing JIT doesn't exist because you don't have stability. Okay. So you cannot say that there's no raw material coming, I want to practice JIT. No, you cannot. You'll only promise to the customer what you can make. The first rule, remove variability, get stability. If you don't have raw material, you keep promising a customer I'll deliver in 14 days time, is wrong. And that is why we talk about Haijunka, tag time. What you can produce, what rate of production, and if you cannot produce, you have to say no to the customer.
Next question is from Mr. Subrata Das. What is Haijunka?
Haijunka, in normal English, I will tell you it is called finite capacity scheduling. Okay. Now, finite capacity scheduling has got a problem because we decide what we have to manufacture and we put it in a sequence. Haijunka has got two parts. For example, you want the load coming on a machine to be 30 minutes. Okay. But your tag time says that one product is required, rate of production is 20 minutes, the other one is 3 minutes, the third one is 7 minutes. Okay. All 30 minutes ho gaya. So if you produce item 1 in one batch, okay, so 20 minutes, you have unbalanced the line. So what Haijunka will do is it'll produce one of 20 minutes, one of 3 minutes, one of 7 minutes. So you get all the three products every hour, but the total load coming on the machine is 30 minutes. So you're going to make sure that the tag time of individual product is maintained and the uneven loading on the machine doesn't occur. Okay. So if you do batching, you are making sure that first you make first item, then you make second item, then you make third item. So third item is waiting, right? It's not coming out every hour. The tag time of that is also per hour. So all the items required every hour are nicely sequenced in such a way that the load fluctuation is evened out.
Next question is from Mr. Atul M. Kulkarni. TPS is based on stability, but post-pandemic during past 2.5 years, we are witnessing unprecedented volatility of demand, factory lockdowns, commodity rates, drastic increase in freight lead time, EMS, plastic shortage from foreign suppliers. Does TPS makes any sense in this non-stable environment anymore, or we need a new approach, for example, make just in case?
There's nothing called made just in case. Yes, if you can't handle so much of variability, then you can move to demand-driven adaptive manufacturing. Okay. However, please understand that TPS was designed for high variety, low volume, right? High variety, low volume. The reason you cannot manufacture low volume because in your mindset you plan to manufacture large batches. And you think if I start manufacturing small batches, I'll become expensive. So if you're going by the first principles of TPS, you can, in this high variability, still manufacture low volume, high variety. For that, you need to make sure that your changeover times are less. Okay, you have a adaptive planning, which can make sure that every hour, 2 hours, you can level the load, which you haven't learned. And hence you find running that your production system to old volumes is what is the good way. Otherwise, moving away from that is called high expense. You have missed, the system you're working on is a combined mixture of high volume and use of Toyota tools, not TPS. So you go to TPS, you reduce your changeover times, you reduce your batch size, okay, and make sure that you don't burden your machines. Okay, you can still cope in this uncertain times.
Another question is from Mr. K. Chakrabarti. Any example of measuring Muda?
Measuring Muda, I said that you reduce the overall throughput time of the item. That is the only measure. If you start saying I've reduced rejections, I've reduced rework, etc., etc., it doesn't work. For example, let us say you have a large batch size. The efficiency of every stage is going to be 100%. But the item coming behind, which has been released for production behind this large batch, has got a huge waiting time and it's got a huge transportation time, right? So if you measure the throughput time of the, not the one you're working on, the one behind, you will realize the impact you can have by reducing the batch size of the item you're working on. So if you're working at Muda, there's only one thing: speed, speed, and only speed, rate of throughput. And if the rate can meet the demand, you are perfect line.
Next question is from Amrita Pandian. Does creating a standard inventory, is it not affecting the flow?
The standard inventory is used to protect the flow. Now I'll give the example. एक road पे पानी आ रहा है, water is flowing on the street and there's a ditch. Okay, it's quite likely that the flow of water is going to stop till the ditch gets filled. And after the ditch gets filled, the water flow carries on, right? The same thing you do in the flow of a system of a production line, Toyota production system. You create enough inventory so that the flow doesn't get disrupted. The idea is to increase rate of flow. Okay, and this is what Kanban does. Kanban tells you how much of inventory you're supposed to keep between two stations so that the flow is maintained. That means down the stream, the manufacturing line doesn't stop.
Okay. Next question is from Somnath Chattopadhyay. What do you mean by N7 norm of mode? Waste of time on hand waiting.
Come, repeat again.
What do you mean by bracket में N7 norms of mode?
Waste.
MUDE
Muda,
here.
Muda.
Okay. Waste
So,
of time on hand. Bracket में waiting.
Waiting, yes. So what happened was when people are being taught the Toyota production system, Taichi Ono was able to say that most of the waste, that means the time which the material is spending on the shop floor, can be classified into these 7 mudas. Okay. And if you can spot these 7 mudas, that means there is after you spot the muda, classify in one of the 7, then you know which tool to use. Okay, so it allowed them to experiment with a concept, and that is why the classification came up. And time on hand is also waste, because you're supposed to start, not keep it in finished goods, okay, and measure everything by reducing time. Okay, I hope I answered it, because I'm not very clear with the question. Okay.
Due to paucity of time, we cannot take up all the questions. Request all the participants, if you have any more questions, you can write down to us. With that, we move ahead with the closure of our webinar. Thank you, Shishir, for such an enriching session. I also thank all the participants for asking relevant questions and making the session so interactive. May I now request all the participants to switch on the cameras, as we would be taking a group photograph for our records. Ashish?
Shishi sir, can you please unshare your screen?
Can I?
Yes, sir. Please unshare your screen.
Oh, sorry. I thought for me it's done?
Yes.
Okay. By the way, just one question. Is anybody here from any of the Toyota companies? Okay.
We have Tata Motors.
Tata Motors. Tata Motors Pune or Jamshedpur?
That I have not analyzed.
Okay, no issues. It's okay. I would have loved to see somebody from Toyota company to narrate how they feel in the part they're working at.
Okay, Ashish, are we done?
No, ma'am. Just wait for a few seconds. I think everyone has not opened their webcam. I can see few faces only. I request everyone to please switch on their webcam.
Ma'am, you may continue, ma'am.
Okay. Thank you for switching on the cameras. With this, we come to the end of this program. And I would like to inform that we will be sharing a feedback form over an email and request everyone to spare some time and provide your feedback with us, as your feedback is valuable to us. Once again, our sincere thanks to Mr. Bharadwaj for his time and valuable insights. We also thank the participants for attending this webinar. I also thank the entire QCI NBQP team that put this webinar together. Thank you and stay safe.
Thank you, everybody.